Good morning, students. In the last class, we are discussing about the topic that is magnetic flux, right? So, magnetic flux is denoted by pi b. I already mentioned that it is similar to that of the electric flux. That means the number of magnetic field lines passing normally through any closed surface. So, that we call as the magnetic flux, right? So, it is denoted by the symbol pi with suffix b, right? So, simply if we write pi, that indicates what? The electric flux. So, we need to mention the magnetic flux means we need to denote with the suffix that is b, right? So, what is magnetic flux? The number of magnetic field lines passing normally to any closed surface or any surface, right? So that we call as the magnetic flux, right? So magnetic flux is denoted by pi b, right? So it is a scalar quantity. So it is a scalar quantity. That means it has only the magnitude but not the direction, right? So its SI unit is Weber, right? So the SI unit is Weber, or in other words, we can also mention Tesla meter square. That is T young square, Tesla meter square, right? So the mathematical form for the magnetic flux pi b, that is equals to BA cos theta, right? So that is the dot product of the magnetic field and the area element, right? So pi b, that is equals to vector b dot vector a, where a is the area element, right? So where b is magnetic field and a area of cross section or area element, right? So when is the magnetic flux is maximum and when is magnetic flux is minimum, right? So when, that is pi b is maximum when theta is equals to 0 degree, right? So when the magnetic flux is maximum, the magnetic flux is maximum when theta is 0 degree. That means the magnetic field and area element both are parallel. So then only the magnetic flux is maximum, right? So when we say that the magnetic flux is minimum, right? So pi b is minimum when theta is equals to 90 degree, right? So that is cos 90 is 0, so 0 into whole term is 0, right? So that's we get the magnetic flux, that is magnetic flux pi b is minimum. Minimum means that value becomes 0, right? So it is important to discuss the next two topics that is mainly based on the magnetic flux. So now next either topic discussed not by the vendor. So magnetic flux plays an important role. So we need to know the relation in mathematical form. So mathematical form of the relation magnetic flux, that is equals to BA cos theta, where B is the magnetic field. So B now indicate not there is the magnetic field, A is the area of cross section, right? So one more concept, that is when it is maximum and when it is minimum, when the theta is 0 degree, that means the magnetic field and the area of cross section both are parallel, then the magnetic flux is maximum. When the magnetic flux, that is magnetic field, is perpendicular to that of the area element, or area element is perpendicular to that of the magnetic field, that the angle is 90 degree. The angle between the two vectors is 90 degree, then theta b is, that is pi b is minimum, that is flux is minimum, and that value is equals to 0, right? So this is about the magnetic flux, right? So next, Faraday law of electromagnetic induction. Faraday's law of electromagnetic induction, right? So in the last class we are discussing about the experiments, that is coil experiment and coil and magnet experiment. In that there is a relative motion between the coil and magnet, right? So due to the relative motion between the magnetic field and to the top of the conductor, so the current is induced. So current induced ಆಗ್ತಾ ಇದೆ ಅಂದ್ರೆ EMF also induced. So first EMF is induced, so that will explains by the Faraday law of electromagnetic induction. So Faraday explained the concept about the EMF which is induced in the circuit, right? So what's the statement given by the Faraday law? So Faraday law ಅಂದ್ರೆ ಏನು ಹೇಳುತ್ತೆ, right? So that is the EMF induced in the circuit is equals to the rate of change of magnetic flux linked with the circuit. So that gives what the statement of the Faraday law, right? So there is EMF is induced, so that EMF is equals to rate of change of flux, right? So that is the relative motion. So relative motion means there is a change in magnetic field, right? So first I will write the statement, right? So what is the statement for the Faraday law means the EMF induced in the circuit is equal to rate of change of, that is equals to rate of change of magnetic field linked with the circuit or loop. So last concept we have taken that one as the loop, or we can consider that one as the circuit, right? So the statement is EMF induced in the circuit. So EMF induced is nothing but EMF produced or EMF generated. So EMF generated in the circuit, so that is equals to rate of change of magnetic field. So rate of change nothing but with respect to time. So time change ಆಗ್ತಾ ಇದೆ ಅಂದ್ರೆ magnetic field ಕೂಡ ಏನಾಗ್ತಾ ಇದೆ ನಮಗೆ change ಆಗ್ತಾ ಇದೆ. So that is rate of change of magnetic field which is linked with the circuit. So ನಾವು ಯಾವ ಸರ್ಕ್ಯೂಟ್ ಜೊತೆ ಅದನ್ನ ಲಿಂಕ್ ಮಾಡಿರ್ತೀವೋ, so ಅಲ್ಲಿ ಏನಾಗ್ತಾ ಇದೆ ನಮಗೆ magnetic field ವೇರಿ ಆಗ್ತಿದೆ. So ಅದು ವೇರಿ ಆಗ್ತಾ ಇರೋದು, that is again with respect to the time, right? So that gives what the induced EMF in the circuit, right? So in mathematically we can write the induced EMF E, that is equals to minus d pi b divided by dt. So this is the statement of the Faraday's, right? So where E is the EMF, so EMF induced or EMF generated, that is equals to minus d pi by dt. So negative sign indicates what the direction of the induced EMF, right? Negative sign indicates the direction of EMF, right? So here rate of change, that is with respect to t. Pi b is the magnetic field. So d represents what small change in magnetic field with respect to small time. So this we call as the rate of change of magnetic field. So that rate of change of magnetic field will cause for the production or generation of the EMF in the circuit, right? So that is given by the Faraday, right? So that is, so in the last class we taken number of coils. So here we considered one coil, right? So to this coil again the coil and magnet experiment, right? So north pole of the magnet is moved towards the coil, so current is generated in the coil, right? So now magnet now move ಮಾಡ್ತಾ ಇದೀವಿ ಅಂದ್ರೆ in the coil the current is generated, right? So this magnet produces the magnetic field, right? So these are the magnetic field lines B, right? So flux ಅಂದ್ರೆ ಏನು, number of field lines passing normally through any surface area, right? So ಯಾವ್ದಾದ್ರು ಸರ್ಫೇಸ್ ಅಲ್ಲಿ ಎಷ್ಟು ನಂಬರ್ ಆಫ್ ಲೈನ್ಸ್ ಪಾಸ್ ಆಗ್ತಿದೆ ಅನ್ನೋದನ್ನ ನಾವೇನಂತ ಕರಿತೀವಿ, ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫ್ಲಕ್ಸ್ ಅಂತ ಕರಿತೀವಿ. ದಟ್ ಈಸ್ pi b, right? So pi b ಮತ್ತೆ b ಗೆ ಡಿಫರೆನ್ಸ್ ಇದೆ, where b is the magnetic field lines, pi b is the number of field lines passing through the given area of cross section, right? So here I am taken the area element in the circular loop. So now iduna non area of the element anta consider madidre. Across this area there are 7 number of magnetic field lines are passing through the cross section, right? So initially 7 magnetic field lines pass aagta ide, so that we call as the magnetic flux, right? So that means 7 Webers, right? So 7 Webers or 7 Tesla per meter square. So if I consider this as area of cross section 1 meter square, then the flux, that is 7 Webers, right? So now when it generates the current in circular coil alli yaವಾಗ ನಮಗೆ current generate ಆಗುತ್ತೆ ಅಂದ್ರೆ when the magnet is moving towards, or it will move away from the coil, right? So ಈ coil ಗೆ ನಿಯರ್ ಆಗೋದ್ರೂ ಅಥವಾ ದೂರ ಹೋಗ್ತಾ ಇದ್ರೂ ಕೂಡ current ಏನಾಗುತ್ತೆ, induce ಆಗುತ್ತೆ, right? So when we move the coil magnet near to the coil, so ಈ magnet ನ coil ಹತ್ರ ಮೂವ್ ಮಾಡ್ತಾ ಇದೀವಿ ಅಂದ್ರೆ that means it is moving with respect to time. So time ಏನಾಗ್ತಾ ಇದೆ, change ಆಗ್ತಾ ಇದೆ. When it moves towards the coil, the number of electric field lines will more across the coil, right? So ಇಲ್ಲಿ flow of the magnetic field lines ಏನಾಗುತ್ತೆ, ಇದು ಹತ್ರ ಕೊಂಡು ಹೋಗ್ತಾ ಇದೀವಿ ಅಂದ ತಕ್ಷಣ number of magnetic field lines ಏನಾಗುತ್ತೆ, ಜಾಸ್ತಿ ಆಗುತ್ತೆ, right? So compare ಮಾಡಿದ್ರೆ same area of cross section, the number of magnetic field lines is more. So ಏನಾಗುತ್ತೆ ನಮಗೆ 10 magnetic field lines, that means flux ಏನಾಗ್ತಾ ಇದೆ 10 Weber. So here flux ಏನಾಗ್ತಾ ಇದೆ 7 Webers, right? So that means flux ಜಾಸ್ತಿ ಆಗ್ತಾ ಇದೆ. So flux ಜಾಸ್ತಿ ಆಗ್ತಾ ಇದೆ ಅಂದ್ರೆ current ಕೂಡ ಏನಾಗುತ್ತೆ, ಜಾಸ್ತಿ ಆಗುತ್ತೆ. So current ಜಾಸ್ತಿ ಆಗ್ತಾ ಇದೆ ಅಂದ್ರೆ EMF ಏನಾಗುತ್ತೆ, ಜಾಸ್ತಿ ಆಗುತ್ತೆ, right? So EMF induced, that is equals to rate of change of magnetic flux. There is change. So ಇಲ್ಲಿ 10 ಇದೆ, ಇಲ್ಲಿ 7 ಇದೆ. So there is a difference. So that difference will be taken delta pi. So ಈ difference ನ ನಾವೇನಂತ ತಗೊಂತೀವಿ, delta pi. That is change in flux, right? So change in flux ಯಾವುದಕ್ಕೆ, with respect to time. So initial case ಅಲ್ಲಿ t is equals to 0 ಇರುತ್ತೆ. When it moves towards the coil, then it takes some time, right? So here the change in time, delta t is equals to 2 seconds, right? So here change in flux, that is 3 Webers, right? So change in flux with respect to change in time, that causes what, the EMF which is used in the circuit, right? So away from the coil ಆಯ್ತು ಅಂದ್ರೆ number of field lines ಏನಾಗ್ತಾ ಹೋಗುತ್ತೆ, ಕಡಿಮೆ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. When it approaches near, then the maximum number of magnetic field lines passing through the cross sectional area, right? So if the coil has more than one turn, right? So previous consider not only the coil which having n turns. So this is the coil which having the n turns, then the flux linked with the coil. So ಇಲ್ಲಿ ನಾವು ಒಂದು magnet na same place ಮಾಡಿ, when it moves towards the coil, then here also it induces the magnetic field, right? So magnetic field ಜೊತೆ ಲಿಂಕ್ ಆಗಿದ ತಕ್ಷಣ here it generates the current, right? So if the coil has n turns, then induced EMF E is equals to minus n d pi b by dt. So this one is the general statement. So include ಆಗ್ತಾ ಇದೆ. Why? Because if the coil has more turns, so n number of turns ಇತ್ತು ಅಂದ್ರೆ 10 turns ಇತ್ತು ಅಂದ್ರೆ n value 10 ಆಗುತ್ತೆ. So 12 turns ಇತ್ತು ಅಂದ್ರೆ n value 12 ಆಗುತ್ತೆ, right? So when and how we can increase the magnetic EMF. So ಇಲ್ಲಿ EMF generate ಆಗ್ತಾ ಇದೆ. ಈ EMF ಯಾವಾಗ ನಮಗೆ increase ಆಗುತ್ತೆ, So here if you observe, E is directly relates with the number of turns. So number of turns na ಜಾಸ್ತಿ ಮಾಡ್ತಾ ಹೋದಂಗೆಲ್ಲ EMF ಕೂಡ ಏನಾಗ್ತಾ ಹೋಗುತ್ತೆ, induced EMF ಜಾಸ್ತಿ ಆಗುತ್ತೆ, and the current which is flowing in the circuit ಕೂಡ ಏನಾಗುತ್ತೆ, ಜಾಸ್ತಿ ಆಗುತ್ತೆ, right? So EMF is increased by increasing the number of turns in the coil, right? So this one is the first case. So EMF na ನಾವು ಯಾವಾಗ increase ಮಾಡ್ಕೋಬಹುದು, ಒಂದು number of turns na increase ಮಾಡಿದ್ರೆ EMF increase ಆಗುತ್ತೆ. So the next one is the magnetic flux. So its EMF is directly related with the change in magnetic flux, that is pi b, right? So pi b is the magnetic flux and it has the relation B to A, where B is the magnetic field and A is the area of cross section, right? So the magnetic field strength na ನಾವು ಜಾಸ್ತಿ ಮಾಡಿದ್ರೆ magnetic flux ಕೂಡ ಏನಾಗುತ್ತೆ, ಜಾಸ್ತಿ ಆಗುತ್ತೆ. So magnetic flux ಜಾಸ್ತಿ ಆಗ್ತಾ ಇದೆ ಅಂದ್ರೆ EMF ಕೂಡ ಏನಾಗುತ್ತೆ, ಜಾಸ್ತಿ ಆಗುತ್ತೆ, right? So by increasing the magnetic field, right? So that one is the second condition. So one do increasing the number of turns. So second one is by increasing the number of magnetic field lines. So number of magnetic field lines na increase ಮಾಡಿದ್ರೆ ನಮಗೆ induced EMF ಕೂಡ ಏನಾಗುತ್ತೆ, ಜಾಸ್ತಿ ಆಗುತ್ತೆ. The next one is area of cross section ಜಾಸ್ತಿ ಆಯ್ತು ಅಂದ್ರೆ magnetic flux ಕೂಡ ಏನಾಗುತ್ತೆ, ಜಾಸ್ತಿ ಆಗುತ್ತೆ, right? So that is by stretching. So stretching ಮಾಡಿದ್ರೆ ರೇಡಿಯಸ್ ಏನಾಗ್ತಾ ಹೋಗುತ್ತೆ, ಈ ಕಾಯಿಲ್ ದು ಜಾಸ್ತಿ ಆಗುತ್ತೆ, right? So area ಜಾಸ್ತಿ ಆಯ್ತು ಅಂದ್ರೆ, so this will taken as area of cross section. So this is A. So ಇವೆರಡಕ್ಕೂ ಕಂಪೇರ್ ಮಾಡಿದ್ರೆ given A, right? So area of cross section in the second coil is more than area of cross section in the first coil. So area ಜಾಸ್ತಿ ಆಯ್ತು ಅಂದ್ರೆ number of field lines ಇದರಲ್ಲಿ ಪಾಸ್ ಆಗೋದು ಕೂಡ ಏನಾಗುತ್ತೆ, ಜಾಸ್ತಿ ಆಗುತ್ತೆ. So magnetic field lines ಜಾಸ್ತಿ ಪಾಸ್ ಆಗ್ತಾ ಇದೆ ಅಂದ್ರೆ magnetic flux ಏನಾಗ್ತಾ ಇದೆ, ಜಾಸ್ತಿ ಆಗ್ತಾ ಇದೆ. So magnetic flux ಜಾಸ್ತಿ ಆಗ್ತಿದೆ ಅಂದ್ರೆ EMF induce ಆಗೋದು ಕೂಡ ಏನಾಗುತ್ತೆ, ನಮಗೆ ಜಾಸ್ತಿ ಆಗುತ್ತೆ, right? So by varying the area, that is stretching the coil. So stretch ಅಂದ್ರೆ ಇಳಿಯೋದು, right? So area of cross section ಅಲ್ಲಿ stretch ಮಾಡೋದು ಅಥವಾ shrink ಮಾಡೋದು. So ನಮಗೆ ಕಡಿಮೆ ಬೇಕು ಅಂದ್ರೆ ಇದನ್ನ ಏನು ಮಾಡ್ತೀವಿ, coil ನ shrink ಮಾಡ್ತೀವಿ. So ಜಾಸ್ತಿ ಬೇಕು ಅಂದ್ರೆ stretch ಮಾಡ್ತೀವಿ, right? So all these factors EMF is increase. So EMF increase ಆಗ್ತಿದೆ ಯಾವ ಫ್ಯಾಕ್ಟರ್ ಇಂದ ಅಂದ್ರೆ, one that is the number of turns in the coil. So coil turns ಜಾಸ್ತಿ ಆಗ್ತಾ ಹೋದಂಗೆಲ್ಲ EMF induced ಏನಾಗುತ್ತೆ, ಜಾಸ್ತಿ ಆಗುತ್ತೆ. Next pi b is the magnetic flux. So magnetic flux relates with the relation B to A, where B is the magnetic field and A is the area of cross section. So magnetic field lines ಜಾಸ್ತಿ ಆದ್ರೂ ಕೂಡ flux ಜಾಸ್ತಿ ಆಗುತ್ತೆ. So flux ಜಾಸ್ತಿ ಆಗ್ತಾ ಇದೆ ಅಂದ್ರೆ EMF ಜಾಸ್ತಿ ಆಗುತ್ತೆ. So area ಜಾಸ್ತಿ ಆಯ್ತು ಅಂದ್ರೆ magnetic flux ಜಾಸ್ತಿ ಆಗ್ತದೆ. So magnetic flux ಜಾಸ್ತಿ ಆಗ್ತಿದೆ ಅಂದ್ರೆ EMF ಕೂಡ ಏನಾಗುತ್ತೆ, ಜಾಸ್ತಿ ಆಗುತ್ತೆ, right? So important statement for 1 marks. So 1 marks ge tumba important statement. Faraday law for electromagnetic induction, right? So simple statement is that the induced EMF in a circuit or in a coil which is equals to rate of change of magnetic flux which is linked with the circuit. So magnetic flux ಯಾವ coil ಜೊತೆ ಲಿಂಕ್ ಆಗಿರುತ್ತೋ ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ, EMF ಜನರೇಟ್ ಆಗುತ್ತೆ. So that is equals to rate of change of flux, right? So idu mathematical statement, so idu theoretical, right? So next is Lenger's law. So statement. The polarity of induced EMF is such that it generates the current which causes the change in magnetic field So this is one more important statement, Lenger's law, right? So now previous Faraday's laws ಅಲ್ಲಿ discuss ಮಾಡಿದ್ವಿ. E is equals to minus d pi by dt, right? So why we taken minus? So that is given by the Lenger's law. So Lenger's law gives the polarity of the induced EMF. So polarity is nothing but the sign. So positive sign or negative sign ಅಂತ ಹೇಳೋದನ್ನ ಯಾವ law ಹೇಳುತ್ತೆ ಅಂದ್ರೆ that is the Lenger's law. So Lenger's law gives the polarity of the induced EMF. So polarity is nothing but sign. Either it may be positive sign or negative sign. So ಯಾವ sign ಅಲ್ಲಿ ನಮಗೆ EMF induce ಆಗಿರುತ್ತೆ, that means positive value ಇರುತ್ತಾ ಅಥವಾ negative value ಇರುತ್ತಾ ಅಂತ ಹೇಳೋದನ್ನ ಯಾವ law ಹೇಳುತ್ತೆ? Lenger's law, right? So the statement is the polarity of the induced EMF, right? So polarity of the induced EMF, that means the sign which generates the current, that means it produces the current, that current is opposes the change in magnetic field. So EMF ಇಂದ ಏನು ಪ್ರೊಡ್ಯೂಸ್ ಆಗ್ತಾ ಇದೆ, ನಮಗೆ ಕರೆಂಟ್ ಪ್ರೊಡ್ಯೂಸ್ ಆಗ್ತಾ ಇದೆ. ಸೊ ಪ್ರೊಡ್ಯೂಸ್ ಆಗಿರೋ ಕರೆಂಟ್ ಯಾವುದನ್ನ ಅಪೋಸ್ ಮಾಡ್ತಾ ಇದೆ? ಚೇಂಜ್ ಇನ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫ್ಲಕ್ಸ್. ಸೊ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫ್ಲಕ್ಸ್ ಚೇಂಜ್ ಆಗ್ತಾ ಇದೆ, ಅದು ಚೇಂಜ್ ಆಗೋದನ್ನ ಅಪೋಸ್ ಮಾಡ್ತಾ ಇದೆ, right? So that gives the statement of the Lenger's law, right? So the polarity of the induced EMF which generates the current, right? So coil na magnet hatra move ಮಾಡಿದ ತಕ್ಷಣ current induce ಆಗ್ತಾ ಇದೆ. So ಆ current ಏನಾಗ್ತಾ ಇದೆ? Opposite ಇರುತ್ತೆ. So that current opposes the change in magnetic flux, right? So ಅದಕ್ಕೆ right? So consider one coil, again consider one bar magnet, right? So now the bar magnet is moved towards the coil. So ಇದು ಎಲ್ಲದಕ್ಕೂ ನಾವು coil and magnet experiment ನ ರೆಫರ್ ಮಾಡೋದ್ರಿಂದ when we move the magnet towards the coil, so EMF is generated in the coil. So EMF generate ಆಗ್ತಾ ಇದೆ ಅಂದ್ರೆ there is a current. So current which is flowing in an anti-clockwise direction, right? So when the magnet is moved, the north pole of the magnet which is moved towards the coil, the current is flowing in the circuit in anti-clockwise direction, right? So then this phase acts as a north pole, right? So current flow of the three directions, right? So in the anti-clockwise direction. So anti-clockwise direction means this phase acts as a north pole. When the magnet is moved towards the coil, coil generates the current in the circuit and which is moving in an anti-clockwise direction, right? So this coil acts as a north pole of the magnet. So current ಯಾವುದಾದ್ರೂ ಒಂದು coil ಅಲ್ಲಿ ಮೂವ್ ಆಗ್ತಾ ಇತ್ತು ಅಂದ್ರೆ ಅದು ನಮಗೆ magnet ತರ ಬಿಹೇವ್ ಮಾಡುತ್ತೆ. So here the north pole is moving towards the magnet, then the current which is flowing in the circuit behaves as a north pole. So from the properties of the magnet, so north pole ಇದೆ, ಇಲ್ಲಿ ಕೂಡ north pole ಇದೆ. So like poles ಏನಾಗುತ್ತೆ? So like poles repel each other. So due to this the magnet will repulse, right? So first ಏನಾಗ್ತಾ ಇದೆ, magnet is moving towards the coil. So current is generated in the coil and the current is moving in an anti-clockwise direction and it behaves as a north pole. So magnet do north pole ಇದೆ, ಇಲ್ಲಿ current produce ಆಗಿರೋ coil ಅಲ್ಲಿ ಕೂಡ north pole ಇದೆ. So due to these north poles, so like poles ಏನಾಗುತ್ತೆ, repel ಆಗುತ್ತೆ. So hence it will move away from the coil. As it moves away from the coil, the current in the coil changes its direction. So now nene discuss ಮಾಡಿರೋದ್ರಲ್ಲಿ galvanometer ಇತ್ತು, right? So not south. When the magnet is moved towards the coil, galvanometer shows the deflection. One side deflection ತೋರಿಸ್ತಾ ಇರುತ್ತೆ. When it moved away from the coil, it shows the deflection in the opposite direction, right? So deflection ಏನಾಗ್ತಿದೆ, opposite direction ಇದೆ. So opposite deflection ತೋರಿಸ್ತಾ ಇದೆ ಅಂದ್ರೆ current ಏನಾಗುತ್ತೆ ನಮಗೆ opposite ಅಲ್ಲಿ ಮೂವ್ ಆಗುತ್ತೆ. So as the magnet is repelled, that means it is moved away from the coil, it changes its direction. So direction ಏನಾಗುತ್ತೆ ನಮಗೆ change ಆಗುತ್ತೆ. So direction change ಆಗ್ತಿದೆ ಅಂದ್ರೆ it behaves as a south pole, right? So ಇಲ್ಲಿ north pole ಇದೆ ಮತ್ತೆ ಇಲ್ಲಿ south pole ಇದೆ. So opposite poles, again what happens, due to the opposite poles again the magnet is attracted by the coil, right? So initially north pole irutte ಮತ್ತೆ north pole irutte, so repel ಆಗುತ್ತೆ. As it moves away from the coil current changes its direction. So when the direction changes, it behaves as a south pole. So magnet having the north pole, so opposite poles ಏನಾಗುತ್ತೆ, again it attracts towards the coil. So this will continues as it is, right? So ಇದು ಏನಾಗುತ್ತೆ, continue ಆಗ್ತಾನೆ ಇರುತ್ತೆ. When it approaches near to the coil, again it changes its direction and the coil behaves as a north pole and same poles repulse each other. When it move away from the coil, again the coil changes its direction, that means south pole. So opposite poles again it attracts each other. So here from this it opposes the change in magnetic field. That means bar magnet motion na ಏನು ಮಾಡ್ತಿದೆ, to and from motion na oppose ಮಾಡ್ತಾ ಇದೆ. So that is due to the magnetic field, right? So that is explained by the Lenz's law, right? So important Lenz's law ಇದು. So 1 marks ಅಲ್ಲಿ ಕೇಳ್ತಾ ಇರ್ತಾರೆ, ಅಥವಾ ಫ್ಯಾರಡೆ ಕೇಳ್ತಾರೆ ಅಥವಾ Lenz's law ಕೇಳ್ತಾರೆ, right? So statement ಕೇಳಿದಲ್ಲ ಇದನ್ನು significance. So what is the significance of the Lenz's law, right? So significance of the Lenz's law is conservation of energy. So significance ಏನಂದ್ರೆ conservation of energy. So 1 marks ಗೆ ಇದು ತುಂಬಾ important, significance. So simple ಇದೆ, conservation of energy, right? So statement ಕೇಳಬಹುದು ಅಥವಾ significance. So in case ಎರಡು ಕೇಳಿದ್ರೆ 2 marks ಗೆ ಕೇಳೋ chances ಇದೆ, right? So state Lenz's law and give it significance ಅಂದ್ರೆ statement ಬರೆದ್ಬಿಟ್ಟು ಜೊತೆಗೆ significance. So significance is conservation of energy, right? So conservation of energy is neither be created nor be destroyed, but it transfers from one form of energy to another form of energy. So that is explained again by the Lenz's law, right? So Lenz's law na ನಾವು ಯೂಸ್ ಮಾಡ್ಕೊಂಡು ಈ ಕನ್ಸರ್ವೇಷನ್ ಆಫ್ ಎನರ್ಜಿನ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡ್ಕೋಬಹುದು, right? So again by taking the same example, so north pole ಯಾವಾಗಲೂ ಕಾಯಿಲ್ ನಿಯರ್ ಮೂವ್ ಆಗ್ತಾ ಇದೆ ಅಂದ್ರೆ ಅಲ್ಲಿ ಯಾವಾಗಲೂ ಕರೆಂಟ್ ಯಾವ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಪ್ರೊಡ್ಯೂಸ್ ಆಗುತ್ತೆ ಅಂದ್ರೆ ಇದು ಆಂಟಿ ಕ್ಲಾಕ್ವೈಸ್ ಡೈರೆಕ್ಷನ್, ರೈಟ್? ಸೊ ಅದಕ್ಕೆ ಕೂಡ ನಾವು ದಟ್ ಬಿ ಟೇಕನ್ ಇನ್ ದ ಸಿಂಬಲ್ ಎನ್. ಸೊ ಎನ್ ಶೇಪ್ ಅಲ್ಲೇ ಅದನ್ನ ನಾವು represent ಮಾಡ್ಕೊಳ್ತೀವಿ. That indicates what? Anti-clockwise direction, right? So when the magnet, north pole of the magnet which is moving towards the coil, so this coil induces the current and which is flowing in an anti-clockwise direction, right? So now move ಮಾಡ್ತಾ ಇದೀವಿ ಅಂದ್ರೆ mechanically we are moving the magnet, right? So that means mechanical energy, right? So mechanical energy is converted into electrical energy, right? Right? So when the current flowing in the coil behaves as a north pole, right? So north pole ಆಗಿ behave ಮಾಡ್ತಾ ಇತ್ತು ಅಂದ್ರೆ ನಮಗೆ ಏನಾಗ್ತಾ ಇದೆ ಇಲ್ಲಿ mechanical energy. Now move ಮಾಡ್ತಾ ಇರೋದ್ರಿಂದ we are moving means mechanically we are doing the work on the object to move, right? So magnet na move ಮಾಡ್ತಾ ಇದೀವಿ, that means mechanical energy is converted into electrical energy, right? So because the current is induced in the coil or induced in the circuit, right? So conversely, if ಇಲ್ಲಿ ನಮಗೆ ನಾರ್ತ್ ಪೋಲ್ ಆಕ್ಟ್ ಆಗ್ತಾರೆ, in case if this behaves as a south pole, when the north pole of the magnet is moved towards the coil, right? So north pole na coil ಹತ್ರ ಮೂವ್ ಮಾಡ್ತಾ ಇದ್ದಾಗ ಇದು ನಮಗೆ ನಾರ್ತ್ ಪೋಲ್ ಆಕ್ಟ್ ಆಗದಲೆ ಸೌತ್ ಪೋಲ್ ತರ ಬಿಹೇವ್ ಮಾಡ್ತಾ ಇತ್ತು ಅಂದ್ರೆ ಏನಾಗುತ್ತೆ ನಮಗೆ south pole, and here it is a north pole. So opposite poles ಏನಾಗುತ್ತೆ ನಮಗೆ attract ಆಗುತ್ತೆ. So attract ಆಗ್ತಿದೆ ಅಂದ್ರೆ this magnet will move faster, that means it gains kinetic energy, right? So mechanical energy is converted into kinetic energy, that means mechanical energy itself is a sum of potential energy and kinetic energy. As it is moving means initially it has kinetic energy, as it approaches near to the coil the kinetic energy is increases, but there is no conversion of energy. So kinetic energy is again kinetic energy tarane irutte, so it violates the law of conservation of energy, right? So that is explained by the Lenz's. So ನಮಗೆ ಎಕ್ಸ್ಪ್ಲನೇಷನ್ ಕೇಳೋದು ರೇರ್ ಚಾನ್ಸಸ್ ಇದೆ. ಸೊ ಎಕ್ಸ್ಪ್ಲನೇಷನ್ ಕೇಳಿದ್ರೆ ಎರಡು ಸ್ಟೆಪ್ಸ್ ಅಲ್ಲಿ ಮೆನ್ಷನ್ ಮಾಡಬೇಕು. when north pole is moving towards the coil, then current is flowing in an anti-clockwise direction and that behaves as a north pole, hence the mechanical energy is converted into electrical energy. So if the north pole is moving towards the coil, if the current which is produced in the coil behaves as a south pole, then the north pole gains the kinetic energy, it violates the law of conservation of energy. So hence from the Lenz's law we can say that which opposes the change in magnetic field, right? So same direction is andre idenagutte, it will move inside the coil with some more kinetic energy, right? So mechanical energy andre namage enirutte idralli sum of potential energy plus kinetic energy. As the magnet is moving, it initially has some kinetic energy and it approaches near to the coil, it attracts and it again gains. So there is no change in energy, that means there is no conversion of energy, right? So illi namage conversion of energy is that is from mechanical to electrical, right? So this is about the Lenz's law, right? So next important one is motional EMF, that is electromotive force, that is motional EMF, right? So important for 3 marks. So this is number 2 marks. So this is for the 3 marks. So what is motional EMF? So motional andre nothing but moving. So EMF andre voltage, right? So electromagnetic force. So here this EMF is not a force, it is a voltage, right? So move ಆಗಬೇಕಾದ್ರೆ voltage produce ಆಗುತ್ತೆ. So ಅದನ್ನ ನಾವು ಏನಂತ ಕರಿತೀವಿ motional EMF, right? So the current is the EMF is induced at the ends of the conductor during its motion, we call that one as motional EMF, right? The EMF is induced at the ends of the conductor during its motion in uniform magnetic field. Right? So ಇದರಲ್ಲಿ ನಮಗೆ ಸ್ಮಾಲ್ ಡಿರೈವೇಶನ್ ತರ ಬರ್ತಾ ಇದೆ. ಸೊ ಅದಕ್ಕೋಸ್ಕರ ಇದು 3 ಮಾರ್ಕ್ಸ್ ಗೆ ತುಂಬಾ ಇಂಪಾರ್ಟೆಂಟ್, ರೈಟ್? ಸೊ ಏನಾಗ್ತಾ ಇದೆ, ಇಎಂಎಫ್ ಇಂಡ್ಯೂಸ್ ಆಗ್ತಾ ಇದೆ. ಎಲ್ಲಿ ಇಎಂಎಫ್ ಇಂಡ್ಯೂಸ್ ಆಗ್ತಿದೆ? ಅಟ್ ದ ಎಂಡ್ಸ್ ಆಫ್ ದಿ ಕಂಡಕ್ಟರ್. ಸೊ ಕಂಡಕ್ಟರ್ ಅಲ್ಲಿ ಇಎಂಎಫ್ ಇಂಡ್ಯೂಸ್ ಆಗ್ತಿದೆ. ಯಾವಾಗ ಇಂಡ್ಯೂಸ್ ಆಗ್ತಿದೆ? ಡ್ಯೂರಿಂಗ್ ಇಟ್ಸ್ ಮೋಷನ್. ಸೊ ಮೂವ್ ಆಗ್ತಾ ಇದೆ. ಎಲ್ಲಿ ಮೂವ್ ಆಗ್ತಾ ಇದೆ? ಇನ್ ಆನ್ ಯೂನಿಫಾರ್ಮ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್. ಸೊ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಅಲ್ಲಿ ಯಾವ್ದಾದ್ರು ಕಂಡಕ್ಟರ್ ಮೂವ್ ಆಗ್ತಾ ಇತ್ತು ಅಂದ್ರೆ ಎಂಡ್ಸ್ ಆಫ್ ದ ಕಂಡಕ್ಟರ್ ಅಲ್ಲಿ ನಮಗೆ ಇಎಂಎಫ್ ಪ್ರೊಡ್ಯೂಸ್ ಆಗುತ್ತೆ. ಸೊ ಅಂತದನ್ನ ನಾವೇನಂತ ಕರಿತೀವಿ? ಮೋಷನಲ್ ಇಎಂಎಫ್, ರೈಟ್? ಸೊ ಫಸ್ಟ್ ಕನ್ಸಿಡರ್ ದ ಯೂನಿಫಾರ್ಮ್ magnetic field. So cross mark indicates what? The magnetic field is moving inside the board or into the plane of the paper, right? So this indicates for the uniform magnetic field B, right? So consider one conductor, so that is in the loop form, right? So ಇಲ್ಲಿವರೆಗೂ ಡಿಸ್ಕಸ್ ಮಾಡಿರೋದು ಎಲ್ಲದನ್ನು ನಾವು ಲೂಪ್ ಅಲ್ಲಿ ಡಿಸ್ಕಸ್ ಮಾಡಿರೋದ್ರಿಂದ so consider one rectangular conductor, right? So P, Q or S, right? So this is one closed loop in a rectangular loop. So closed coil ಅಂತ ನಾವು ಏನು ಕನ್ಸಿಡರ್ ಮಾಡ್ಕೊಂಡಿದ್ವಿ? ಸರ್ಕ್ಯುಲರ್ ಕಾಯಿಲ್. ಸೊ ಇಲ್ಲಿ ನಾವು ಕನ್ಸಿಡರ್ ಮಾಡ್ಕೊಂಡಿರೋದು rectangular loop, right? So which having length L and breadth X. So area ಇದೆ, area ಏನಂತ ತಗೊಂಡಿವಿ? Length into breadth, that is L into X. So magnetic field ಇದೆ, right? So ನಮಗೆ ಇಲ್ಲಿ EMF induce ಆಗ್ತಾ ಇದೆ when the arm PQ. So ಇದು ಮಾತ್ರ movable ಆಗಿರುತ್ತೆ. In all remaining others are fixed, right? So considered a rectangular conductor such a way that the arm PQ is movable, right? So that arm PQ will be moving in an uniform magnetic field. So this arm is moving in the magnetic field with velocity v, right? So where v is the velocity of the conductor. So arm ಅಂತನಾದ್ರೂ ಹೇಳ್ಬೋದು ಅಥವಾ ಕಂಡಕ್ಟರ್ PQ ಅಂತನಾದ್ರೂ ಹೇಳ್ಬೋದು. ಸೊ ಇನಿಷಿಯಲಿ ಏನ್ ಮಾಡಿದೀವಿ? ಒಂದು ಕಂಡಕ್ಟರ್, ರೆಕ್ಟಾಂಗ್ಯುಲರ್ ಕಂಡಕ್ಟರ್ ಕನ್ಸಿಡರ್ ಮಾಡಿದೀವಿ. ಸೊ ಆ ಕಂಡಕ್ಟರ್ ಅಲ್ಲಿ ಆರ್ಮ್ PQ ಅನ್ನೋದೇನಾಗುತ್ತೆ? ಮೂವಬಲ್ ಇರುತ್ತೆ. ಸೊ ಆಲ್ ಅದರ್ ರಿಮೈನಿಂಗ್ ಆರ್ಮ್ಸ್, ದಟ್ ಈಸ್ SP, SR and RQ. ಸೊ ಇದಿಷ್ಟು ಆರ್ಮ್ಸ್ ಏನಿರುತ್ತೆ? ಫಿಕ್ಸ್ಡ್ ಇರುತ್ತೆ. So the arm PQ is moving with velocity v. So velocity is change in displacement with respect to time, right? So now as the conductor is moving in the magnetic field, so this rectangular loop or rectangular conductor having magnetic flux. So namge area ide, magnetic field ide, right? So magnetic flux in the rectangular loop, that is pi b, that is equals to b into a, right? So this is from the definition of the magnetic flux. So B is the magnetic field and A is the area of the rectangle, right? So pi B, that is equals to B into area is L into X, length into breadth, right? So now when the conductor is moving, so from the definition at the ends of the conductor EMF is induced, and that is given by the Faraday laws of motion, that is induced EMF E, that is equals to minus d pi b by dt, right? So we know the value of pi b, so d by dt. So pi b, that is b L X, right? So ನಮಗೆ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಅಪ್ಲೈ ಮಾಡಿರೋದು ವ್ಯಾಲ್ಯೂ ಏನಿದೆ? ಕಾನ್ಸ್ಟೆಂಟ್ ಇದೆ. ಸೊ ಈ ಲೆಂತ್ ಕೂಡ ನಮಗೆ ಕಾನ್ಸ್ಟೆಂಟ್ ಇದೆ. ಲೆಂತ್ ಏನಾದ್ರೂ ವೇರಿ ಆಗುತ್ತಾ? ಕಂಡಕ್ಟರ್ ಇನಿಷಿಯಲಿ ನಾವು 5 ಸೆಂಟಿಮೀಟರ್ ಅಂತ ತಗೊಂಡ್ರೆ ಇದು ಲೆಂತ್ ಸೇಮ್ ಇರುತ್ತೆ, ರೈಟ್? ಸೊ L is constant. So then what about X? So X is the breadth. As it is moving, X value ಏನಾಗ್ತಾ ಇದೆ? ನಮಗೆ ಚೇಂಜ್ ಆಗ್ತಾ ಇದೆ. So as it is moving somewhere here, so the value of X is decreased, right? So now dx and that is change in the displacement, right? So as this PQ is moving with some velocity v, so the breadth ಏನಾಗ್ತಾ ನಮಗೆ change ಆಗ್ತಾ ಇದೆ. So this is not constant, right? So constant ನಾವು ಹೊರಗಡೆ ತಗೊಂಡ್ರೆ minus bl dx by dt, right? So from the definition, change in displacement with respect to time, we call that one as velocity, right? So the induced EMF E is equals to minus BLV. So where V is equals to dx by dt, right? So ಇದು ನಿಮಗೆ ಡಿಫರೆನ್ಷಿಯೇಷನ್ ಕ್ಲಾಸ್ ಅಲ್ಲಿ ಮಾಡ್ತಾ ಇದ್ದಾರೆ ಅಂತ. ಸೊ ಕಾನ್ಸ್ಟೆಂಟ್ ಟರ್ಮ್ಸ್ ನ ಏನು ತಗೋಬಹುದು ನಾವು ಹೊರಗಡೆ ತಗೋಬಹುದು. ಸೊ ಓನ್ಲಿ ದ ವೇರಿಯಬಲ್ ಟರ್ಮ್, ದಟ್ ಮೀನ್ಸ್ ಯಾವುದು ಚೇಂಜ್ ಆಗ್ತಾ ಇರುತ್ತೋ ಅದನ್ನ ಡಿಫರೆನ್ಶಿಯೇಟ್ ಮಾಡಬಹುದು, ರೈಟ್? ಸೊ ದಟ್ ವಿ ರಿಟರ್ನ್ dx by dt. So that value is called as velocity, right? So E is equals to minus BLV. So this is called the motional EMF. So 3 marks get important. So diagram next. So this one is the magnetic flux. This one is induced EMF, right? So as the EMF generate ಆಗ್ತಿದೆ ಅಂದ್ರೆ minus BLV. So magnitude of E, so always we take on that one as positive value, that is BLV, that is magnitude of EMF. Right? So it will be a continued part of the energy consideration, so that we will discuss in our next class. Thank you.